So this isn't the normal setup that I do this with, so you're gonna have to bear with me and hope that this works out okay. This is the highlight video for section 4.5, and I'm gonna start out with a yellow highlighter. It's about medians, altitudes, and bisectors, and most of what's in this section is stuff that I need to be able to point at anyway, so I decided to try it this way. We'll see if I can get everything covered or not. I'm going to start out with the definition of a median, and we're talking about the median of a triangle. If and only if it extends from a vertex of the triangle to the midpoint of the opposite side. So basically, it looks like this stuff down here. These are all medians. You can tell they're medians because it's split each side into equal parts. Now notice that none of these have to equal the other ones. The other thing I want you to notice is that none of those are angle bisectors at all. There's nothing that says that this angle right here is the same as that angle right there. However, when we talk about an angle bisector in a triangle, it has to bisect the angle of the triangle and have an endpoint on the opposite side. So these are all angle bisectors, and we can tell that because they marked our angles for us. And these lines always go to the opposite side. So PD is the angle bisector for angle P in that triangle. Angle bisectors don't necessarily, in fact, you can tell because these are the exact same triangles. Angle bisectors are not necessarily the same lines that an angle median, that a triangle median is. So here, the angle bisector actually ended up a little bit higher than where point A would be down here for the median. So you need to make sure that you understand the difference between a median of a triangle and an angle bisector in a triangle. Okay, let's see if this method works or not. Ooh, very nice. Oh, I like it. Okay, page 2. We have to talk about altitudes, and altitudes are actually much more interesting, I think, personally. They're not as easy to see, though. A segment is an altitude of a triangle if and only if it goes from the vertex to the opposite side and forms a perpendicular on that opposite side. So here we have an altitude going from M to this side, and I know that that's the altitude because that's where the right angle is. Here we have a right angle, and notice how far down it is. That's okay. And here we have one. Now, what this other stuff is saying is that it depends on what kind of triangle it is as to whether or not they're going to intersect inside on the triangle or outside the triangle. Now, these three lines don't have to intersect at the same point. It looks like they do, but technically they're really not quite on the same point. Sometimes they do, but here they don't have to. These definitely intersect at the same point because they all intersect at D. These might intersect at the same point, but you would have to extend those on out. So this one goes out that way, this one comes down this way, and that one goes that way. Your triangle, however, was right here. But the altitude is there, here, and here. So our altitudes could extend out, but don't necessarily have to cross. This line right here is not an altitude because this is not part of our original triangle. when you have an altitude of an obtuse triangle, they're going to end up having the right angle outside the triangle for most of the sides. Not for all the sides, obviously, but for most of them. Okay. So down here, they just wanted you to say whether it was going to be an altitude and what it really meant. So if they tell you it's a median, you know that that means that these are going to be congruent. If they tell you it's a bisector, you know that means that my angles are going to be congruent. And if it tells you that it's a perpendicular bisector, it means it's perpendicular and they're congruent. In a little while, we'll learn some other stuff about it. But these do not allow you to just jump to congruent triangles. Because we have one angle and one side does not mean that these two are congruent triangles. We do have one side right there, but it doesn't mean that they are congruent triangles. In fact, they don't look like they are at all. Same thing over here, we have two sides, but we don't know that those two would make congruent triangles. Over here, we have two sides and an angle. So later on, you'll find out that that does make for congruent triangles. Now, there's a theorem down here. Theorem 4.2. It's the only purple I have with me right now to highlight with. So if a point lies on a perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. In other words, you can make a triangle with it if it lies on the perpendicular bisector. Here's a nice little perpendicular that I'm going to say is bisecting this line. So I'm going to go ahead and mark it. And what that means is that this endpoint and this endpoint must be exactly the same from that point. And even if I choose this point to be my point, it would be exactly the same. It helps if I could draw better, but you get the idea. That's what that is saying. And then if a point is equidistant from the endpoints, then it must be on the perpendicular bisector. That's the same thing in a different order. And then if 2 points are each equidistant from the endpoint of the segments, then the line joining them are points on the perpendicular bisector. Probably not going to use these, but we'll put them in there anyway. Look, they're kind of shiny. And if a point lies on the bisector of an angle, then the point is equidistant from the sides. In other words, if a point is here and is perpendicular, then it's going to be equidistant from both. As long as this is the bisector, it would have to be equidistant from both. So R is equidistant from C and T. And if a point is equidistant from the sides of the angle, then the point lies on the perpendicular bisector of the angle. Ta-da! Okay, so now you have those. You know you need to put the yellow stuff, which is really what's most important in this section, on your definitions page. You need to put the purple stuff on your theorems and corollaries page, and I will go through some of the few problems that you're going to have for homework and classwork on the classwork video. Okay, bye.